as people now maybe having access to the internet and having running water and electricity, we just tend to forget that. But I think it was the idea, the pedagogical idea and notion of we need to actually be the sage and the stage while still having a fatherly or a motherly touch when it comes to our students. So still guiding them when we can, but actually being the sage on the stage, and don't expect them just to get going with everything. So I think we need that to be shared in
perfect.
another session.
We're going to do that.
Yeah. Thanks. So Shakila, I don't know if we must still wait. Or are we ready to start? I don't think we can wait because we should start by 2:15 because we have to end it.
I think all the rooms are coming in now, so they should all be coming in. Just give them 2 minutes.
Okay, so I'll wait. Great. I'll wait for the sign to leave, and then I'll just introduce Prof. Msiza, and then he can take it away.
Yes. Yeah.
Okay.
But in the meantime, I can share my screen and see if everything is in order.
You can go for that, Prof. I think that's a good idea. I can see mathematics show.
Is it visible?
It's visible. It's a bit more tiny. I can see it, but it's a little bit tiny. So I don't know if it's me. Maybe I'm not understanding it. Okay, it's better now. I've gone to a full screen option.
Full screen. Okay.
Yeah, I've gone into full screen. So now I'm exiting full screen.
From when I take this down, you will start, and then I'll start recording, right?
Shakila, have you taken it down? I still see the welcome slide.
I haven't taken it down as yet.
Okay.
When this comes in, then you can. I don't see the numbers going up.
Yes, so I was thinking you should start because I think they're going to be running away.
Okay, all right. I'm going to start now recording, and then I'm going to take the screen down, right?
Right. Welcome back, attendees, delegates and speakers. I'd like to introduce our Professor Msiza Mkhize, who's going to be talking about and entertaining us with demystifying mathematics for the next 10 minutes. Thank you, Prof. Take the floor.
Thank you, Prim. Colleagues, can you see my screen?
Yes, Prof.
We can see it.
Thank you very much. This is just a mathematics show. I'll be just entertaining you. Well, I'm going to put the excitement back into mathematics. That's what I normally do. The show leads learners to talk mathematics, speak maths, If you speak maths, you're going to love it, pass it, and see it as an interesting subject, as a fascinating subject. Did I greet you? Did I greet you, colleagues?
Yes, Prof.
I forgot. How are you today? Please, I want answers, colleagues. This is interactive. How are you today? Yes, just talk.
We're good, but we're tired, Prof. And I see
Good and
Siyabonga and
tired.
Kambelo says we are good. So Siyabonga says we're good, Prof.
Oh, number one. Look, students, sometimes they say I'm fine. Fine like a fine salt. You can't say I'm good. We are rated last in mathematics. The World Economic Forum rates South Africa last in maths. Therefore, we have to encourage our students to talk maths, to speak maths. If I say, how are you today? I ask you, how are you today? You mustn't say I'm fine. You mustn't say you must say I'm positive. Even indicate with this hand, because this hand is strong, it's like a plus, I'm positive today. If you are not fine, you must indicate with the left-hand side because it's weak, I'm negative today. So you must talk maths, you must speak mathematics, speak maths. No, today I'm greater than zero. Greater than zero, where is zero? Your head is zero, therefore I'm greater than zero, or I'm less than zero. Or you can even say I'm equal. The left-hand side is equal to the right-hand side. No, if I'm not equal, so it means you are not fine. By the way, if you do this, your head, this is a number line. Your head is the neutral point, which is zero. The right-hand side is your plus, and then the left-hand side is your negative. This is your number line. Your head is zero, the neutral point. And you can say today, I'm rational. I'm just like the square root of 4, the square root of 25, the square root of 49, the square root of 81. No, I'm just like the square root of 2, I'm irrational. Just like the square root of 2, the square root of 5, the square root of 7. Meaning that you are not fine. No. Today, I'm proper like a proper fraction. No, today I'm improper. I'm like an improper fraction because you get a mixed fraction. No, today I'm 100%. Today I'm less than 100%. Today I'm straight like a straight line. If you want my gradient is the same at any point. No. I'm like a curve today. I'm not fine. If you want my gradient, you must use calculus. Get a derivative. So we have to encourage our kids to talk maths, to speak maths. Oh, this morning we were supposed to start with an opening prayer. We forgot to put it as part of our program. We forgot to put it. We were supposed to start with an opening prayer. Okay, fine. I've got a verse. Luke 6, verse 29. If someone slaps you on one cheek, turn to him the other also. This is Luke 6, verse 29. In maths, we say, whatever you do on the left-hand side, you must also do on the right-hand side. We also talk about that in accounting. We also talk about that in physical science. When you talk about equations, whatever you do on the left-hand side, you must also do on the right-hand side. Hey, that is from Luke 6, verse 29. So you get maths from church as well. Who created the numbers? The answer that I normally get, they say it's Arab, Egyptians, Greeks, God. The person who created the numbers is my father. My father created the numbers. He created 0 up to 9. He said 0 up to 1, up to 4, we're going to write like this. He started with these numbers. And he said to get a 5, you must take a 2 and turn it upside down. Take a 2 and turn it upside down. These 2, you just turn it upside down, you get a 5. To get a 6, take a 1 and make a 0 small and combine that. And then you get a 6. To get a 7, take a 4 and write it like this. To get an 8, take a 3 and complete it. And to get a 9, take a 6 and turn it upside down. My father was brilliant. He was out of this world. When I was doing grade 2, I had a problem with the multiplication of 9. He said to me, no, the numbers that I developed, write the numbers vertical, start from 0 up to 9. I did that. And he said to me, now it is 0 up to now, 9, now start from 9 now to 0. You must put that now on the right-hand side, of which I did that. And he asked me a question, what do you notice? I said, this is a multiplication of 9. 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36, 9 times 5 is 45, 9 times 6 is 54, 9 times 10 is 90. He asked me another question. What do you notice? I said, if you add the answer, 0 plus 9, you get a 9. 1 plus 8, you get a 9. 2 plus 7, you get a 9. 3 plus 6, you get a 9. 4 plus 5, you get a 9. He asked me another question. What do you notice? I said to him, any number multiplied by 9, if you add the answer, you get a multiple of 9. For example, 11 times 9 is 99. If you add 9 plus 9, you get 18. 18 is a multiple of 9. 111 times 9 is 999. If you add 9 plus 9 plus 9, you get 27. 27 is a multiple of 9. 12 times 9 is 108. If you add 1 plus 0 plus 8, you get a 9. A 9 is a multiple of 9. 123 times 9 is 1,107. If you add 1 plus 1 plus 7, you get a 9. A 9 is a multiple of 9. So my father was very happy. And then he even said to me, the multiplication of 9, 9 times 1 is 9, 18, and 36. And then he said, now another method of doing the 9 times table. To get the 9 times 6, you just reverse your 45, you get 54. To get 9 times 7, you reverse your 36, you get 63. 9 times 8, you reverse your 27, you get 72. 9 times 9, you reverse your 18, you get 81. 9 times 10, you reverse your 9, you get 90. So the multiplication of 9 is fascinating. And he even said to me, you can even use your fingers for the multiplication of 9. He said, we have 10 fingers. And when we count from left to right. So I've got fingers. He said, now this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. He said, now for 9 times 1, you just fold down this finger and you get 9 times 1. What you get is 9 fingers. And then 9 times 2, he said, fine. Now unfold 1, fold down 2. If you fold down 2, the answer that you get is 18, 9 times 2. So there is 1 here, and then there's 8 fingers this side. And then he said, for 9 times 3, you fold down 3, and then with the answer 9 times 3 is 27. He said, this is your 2, and then now 27. 9 times 4 is 36. 9 times 5 is 54. 45. 9 times 6 is 54. 9 times 7 is 63. 9 times 8 is 72. 9 times 9 is 81. 9 times 10 is 90. So I've got 9 fingers plus 0 this side, which is 90. So the multiplication of 9 is interesting. You can use your fingers. We often encourage our kids to memorize the multiplication of numbers, of which is wrong. They can use the fingers. For example, even the multiplication of 6 to 10. Kids can use fingers for the multiplication of 6 to 10. For example, this is 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. For 9 times 9, you just put down you put the fingers together, and now here you've got 8, and there's 1 times 1. 1 times 1 is 1. You've got 8 fingers, which is 81. 81. Now, if you say 8 times 8, you've got 6 fingers here, 6 fingers. There's a 2 this side and a 2 this side. 2 times 2 is 4, and then you get 64. And 7 times 7. So we have a 4 fingers here. 3 times 3, it's a 9, is 49. And you can say 9 times 7. 9 times 7 is 63. So we have 6 fingers here. We have 6 fingers here. 3 times 1, 3 times 1 is 3. Therefore, it's 60, 60, 63. So we can use fingers for the multiplication of 9. So there's no need to memorize the multiplication of numbers. So let us encourage our kids not to memorize the multiplication of numbers. Pythagoras theorem in a process of becoming a chartered accountant, how to become a CA. I use the Pythagoras theorem to explain how to become a chartered accountant. I discovered this. To become, in fact, in Pythagoras theorem, we say in a right-angled triangle, the area of a square on the hypotenuse is equal to the sum of the squares on the other, is equal to the areas of the squares on the other two sides. Now, to become a chartered accountant, you must pass matric and join one of the universities, and you do BCom accounting over a period of 3 years. You add another year for your honors, or also called certificate in theory of accounting. So you spend 4 years at university. And the area of this square now is 16 square meters. If you pass your university studies, then you must join one of the universities one of the accounting firms for training. You train over a period of 3 years. You train over a period of 3 years. You train over a period of 3 years, and the area now is, for this square, is 9 square meters, 9 square meters. And during the time you train, you write exams set by SICA. We have ITC1, ITC1 in initial test of competency. You write it in your 5th year. Your first year of training, which is your 5th year, you write the ITC1, the initial test of competency. So the area now of this square is 25 square meters. So if you add 16 plus 9, you get 25. 16 plus 9 is equal to 25. So if you pass the exams and you complete your 3 years of training, then you register with SICA now as a chartered accountant South Africa. This is a process how to become a chartered accountant using the Pythagoras theorem. Please acknowledge me if you use it, because this one is mine. Please acknowledge Professor Msize Mkhize, this is mine. I'm the founder of this. Maths, students can also use maths. Geometry is a problem. Some students do not write geometry part at school level. So they can use the word maths to play with it. For example, M, the angles subtended by the chord and the arc are equal. And O, we talk about the exterior angles equal to the sum of the two interior opposite angles. And T, it's 90 degrees. The line is perpendicular there. And H, we talk about alternate angles because we have parallel lines. And E, we talk about corresponding angles because we have parallel lines. We also talk about co-interior angles because we have parallel lines. And here, the angles subtended by the chord and the arc are equal. And here we talk about proportionality theorem. The sides are proportional. And for the T, here, the tangent is perpendicular to the diameter. I, which is a straight line is 180 degrees. And C is for complementary angles. Adjacent complementary angles add up to 90 degrees. And S is for supplementary angles. S has got two C's, therefore 90 degrees plus 90 degrees. So the adjacent supplementary angles add up to 180 degrees. I also discovered that vowels, we can use vowels in geometry. The traditional way of writing the vowels. For example, A, we have the circle and the line. This line is a tangent because it touches the circle here. And if you put a triangle inside, we talk about the tan chord theorem, grade 11 geometry, grade 12 geometry. We talk about the tan chord theorem. The angle between the tangent and the chord is equal to the angle in the alternate segment. And if you draw a diameter is perpendicular to the tangent. Therefore, if we say the tangent is perpendicular to the diameter, is perpendicular to the radius, and the line drawn from the center is also perpendicular to the chord. I'm talking about the theorems here. I get the theorems if I use my A. And E, we have a semicircle there. We say the angle in a circumference is 90 degrees. So the angle at the center is twice the angle at the circumference. At the center is 180, therefore at the circumference is 90. So the angle at the center is twice the angle at the circumference, grade 11, grade 12 geometry. And I is for the straight line, which is 180 degrees. And O, if you put a quad inside, we talk about cyclic quad. And the opposite angles of a cyclic quad add up to 180 degrees. The opposite angles add up to 180 degrees. And U, if you put a circle and you close your U, the exterior angle is equal to the interior opposite angle. And we say the angles subtended by the chord and the arc are equal. Angles in the same segment are equal. This is grade 11, grade 12 geometry. I've just summarized it. They take about a month or two working on this. Just summarize it in just a few minutes using the vowels. I discovered this. So please acknowledge me if you use it. Using mathematics to understand the basic accounting principles, and we use the principles even here at tertiary level at university. Basic education, they use the principles. We also use the principles here. We talk about the accounting equation. This is the accounting equation. We said assets are equal to owner's equity plus liabilities. Therefore, to get the rule that we use, we talk about T account. We talk about T accounts. So this is a T, and then the asset rule. The assets are on the right hand or left hand side. Therefore, we say it's a plus. So we do not have the assets on the right hand side. Therefore, it's a minus. But using maths, A is positive on the left hand side. So if you transpose your A to the right hand side, the sign changes to negatives. So that is why we get this using mathematics. And then for the owner's equity rule, O is on the right hand side. So we do not have O on the left-hand side, therefore it's a minus. Using maths, O is positive on the right-hand side. If you transpose O to the left-hand side, the sign changes to negative. And even the liability rule. The liability rule, L is positive. We have liabilities on the right-hand side. We do not have liabilities on the left-hand side. Therefore, it's a minus. Oh, yes, on the right-hand side, L is positive. If you transpose L to the left-hand side, therefore the sign changes to negative. So these are the rules that we use in accounting. These rules are derived from the accounting equation. The father and the founder of this is Lucas Possiolo, the Italian guy. He's the one who discovered this. He was a mathematician. And you can use this to remember the accounting equation. At home, they know if we eat eggs, they say we eat accounting equation because they know the shell contains two things, the yolk and the liquid part. That's why we have assets. Assets contains two things, owner's equity and liability. So the shell now is like your assets. Your owner's equity, that is your yolk, because it is owner's wealth. The owner is interested there. The net worth, because it is healthy. And then the liquid part, we talk about liabilities. So that's why we say, oh, the assets, the shell contains two things, the yolk as well as the liquid part, which is the same as what you call the accounting equation. So if you eat an egg, you must know that, hey, I eat accounting equation. You can use maths to explain the double entry principle. I was challenged by a student in my class. Who said to me, who asked me a question, why say in accounting we debit and credit and credit and debit? Why don't we debit and debit, credit and credit? Why do we debit and credit, credit and debit? What if I want to debit and debit, credit and credit? Please explain, sir. So this is what I used to explain. I said to the student, you know what, I'm Sisi, and my right-hand side is strong, is a plus. The left-hand side is weak, it's a minus. And my wife is Neti, and the right-hand side is a plus, and then is a minus, the left. At the end of each month, I give her 5,000 rand for grocery. I'm not sure whether this is correct, but 5,000 rand for groceries. But I use my weak hand. Because if I receive with a strong one. If I give with the weak one. So I gave him 5,000 rand, and she received with a strong hand. So it's a plus because she's receiving. So that's why in accounting we credit and debit. But she said, no, I know that, hey, this month you're not okay. I'm going to give you back. I'm going to give you 2,000 rand. And then she used her weak hand, and I received with a strong one. So that's why we debit and credit in accounting. The double entry system that we use in accounting. So in accounting, we do not debit, credit. We debit and credit, we credit and debit. Because of the equation, the left-hand side must be equal to the right-hand side. That's why we prepare a trial balance at the end of the day, where your debit side must be equal to the credit side. Oh, Jesus Christ cross. They say Jesus Christ was crucified on the cross. And I told my pastor that, no, pastor, this is a Cartesian plane. We use it in mathematics. This is a Cartesian plane. Here we have the 4 quadrants. The first, the second, the third, and the fourth quadrant. We even used it in trigonometry. We use it in algebra. This is the Cartesian plane. We use it in maths to draw the graphs. We use it to draw the graphs even in economics. In economics, we use the first quadrant. We say it is the economic relevant region where we draw the supply curve, the demand curves. We also talk about linear programming, which is also used in mathematics. We talk about that in economics, but we use the first quadrant because it is the economic relevant region. Maths is also even used in physical science. Some teachers, they teach in isolation. Maths is maths, physical science is physical science. But they must show the students the link. For example, this is the gradient. This is the quadratic equation, sine graph, hyperbole. We talk about derivatives here, sine rule, the cosine rule, Pythagoras theorem. We also talk about geometry in physical science. Yesterday at home, we ate fish and chips. At home, they know before you eat, you must talk maths. Before you eat, you must talk maths. Before I ate my fish, this is what I did. I said to them, give me a pen and a paper. I said, this is a cubic curve with where A is positive. And then I said, this is a cubic curve where A is negative. And I said, let me put an angle, and then I decided to put a tail here. And then I said, this is a fish. So it means today we're eating mathematics, we're eating cubic curves. And then they said to me, now you can eat your fish because now you spoke about maths. My daughter said, no, okay, fine. Where are my chips? And then she said, all right, these are my chips. And then she said, okay, 2 chips, parallel lines. And then she put a transversal. And then she said alternate angles, corresponding angles, co-interior angles, vertical opposite angles. I said, fine. And she even spoke about polygons as well. She spoke about triangles, she spoke about quadrilaterals, she spoke about hexagon, she spoke about decagon, nonagon. And then we said, now you can eat your chips. Even if we visit McDonald's, before you eat your burger, you must talk maths. Hey, circle round, there's a diameter, there's a radius, there's a major segment, minor segment. Therefore say, now you can eat. Drinks, what about drinks? No, I can calculate the volume. What is your formula? And then they'll give you the formula. And then, okay, you can drink. I wrote an opinion piece about teaching mathematics needs creativity and a touch of magic. Teaching mathematics needs creativity and a touch of magic. So please, this is available on the internet. It's available on the internet. Please read it. You're going to get interesting ideas from Professor Mkhize. By the way, I wrote this article when I was Dr. Mkhize. Finally, let me share a poem written by my son. He was doing grade 11 at Pinetown Boys High School. My expression for the love of mathematics. I'm a mathematician. I'm good with numbers. I'm good with figures. I'm good with algebra. I'm good with geometry. I'm good with trigonometry. They call you a killer subject. They hate you. They have a negative attitude towards you. They avoid what is difficult. They go for what is easy. Tell them you are everything. Tell them world is mathematics. Tell them scientists use you. Tell them engineers use you. Tell them accountants use you. Tell them everyone uses you. You have many names. They call you core mathematics. They call you pure mathematics. They call you mathematics science. You need strong-minded learners. You need industrious learners. You need innovative learners. You help us to think outside the box. You help us to think critically. You're my friend, mathematics. Your sister, mathematical literacy, is my friend too. She takes care of those who are afraid of you. Your relatives are my friends too. Until science, and geography, nephew accounting, niece economics. The future of the country must not be compromised. Fellow learners, go for mathematics. Your future lies in mathematics. Thank you very much. This is the end of the presentation. Thank you very much.
Thank you, Prof. If you could please stop screen share. Thank you so much for an enlightening, informative, entertaining session. In fact, the participants have written there, I needed this in primary school. I was going to be a force to be reckoned with. Well done, Prof. Amazing, Prof. Ingeke, Prof. So thank you so much for that wonderful presentation. It was truly appreciated. Ladies and gentlemen, attendees, speakers, thank you, Prof. Ladies and gentlemen, attendees, speakers, participants, we're concluding today's session. Today was day 1 of the Academic Monitoring and Support Colloquium. I want to sincerely thank all of you for making the time to attend the session and in participating in the presentations. We look forward to seeing you for tomorrow's session. We will be concluding with the morning session tomorrow. We will start 9 a.m. Promptly, and we'd really love to see all of you there once again. Take care and have a lovely afternoon. On behalf of the AMS Colloquium Steering Committee, thank you, and we'll see you tomorrow. Bye-bye.
Thank you.